Hi, in this video, we're going to talk about the ambiguous case. It's part of section 5 and section 6 of chapter 5. So what does the ambiguous case mean and how do we handle this case? First of all, we have some measurements given of a triangle. In a sample problem that I'm going to be working on, we have angle A, which measures 42 degrees, side A that measures 7, and side B that measures 10. So just a quick reminder, with the law of sine, we used AAS or ASA. So for example, if I end up with a triangle that has those given measurements, this case, two angles and a side that is not included, or two angles and an included side, we use the law of cosine. The law of sine to solve for this triangle. If we have side, 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 or side angle side, so either three given sides or two given sides and an included angle, we use law of cosine to solve for that triangle. In case we're given three angles, there's no way to solve for the triangle. So keep in mind our purpose, our objective is to solve for the triangle, which means finding the missing parts of a triangle. A triangle has three sides, three angles. We're going to divide this task into two parts with the ambiguous case because it's kind of lengthy to solve for the triangle and there is a decision to be made before we can solve for this triangle. So first of all, we're going to set up the triangle with the given measurements, and I'm reading the steps, and decide which case it is. So we can decide which law to use. So if I form the triangle, and I have angle A given as 42 degrees, I have side A, which usually faces angle A. Side B is given, which faces angle B. And I am missing some of the parts of the triangle. I need to see what I have. So I have one side, I have another side, so I have two sides. So SS, and I have an angle given, but this angle is not included in between the two sides. So that's why kind of this angle is kicked out. So it's SSA. If this was an SAS, it would have been like that, 10, 7, 42. That's SAS, and this is when we use the law of cosine, but it's not. It's SSA, which means it's an ambiguous case, and it's not as easy as the other cases, and there's a decision to be made. Now, let's take a look at the three possibilities. The three possibilities include something that says H, H, H. And I think I typed it here. It's the height. So let's try to recall, what does a height in a triangle means? The height is a line segment that is perpendicular to a side of a triangle. So we could make three line segments that represent three heights in a triangle. This is one of them. This is another one. Trying my best to make it perpendicular. And this is a third one. So we could form three heights in a triangle. Now, we don't need to draw all three. We just need to draw the height that is perpendicular to the missing side. So I'm missing this side. I'm going to draw the height that is perpendicular to this missing side. And the height is perpendicular to the side. So that's why I put that 90-degree angle. And then what do we do after? And what does it have to do with the height? So we need to calculate the height. To calculate the height, we're going to use a right angle triangle. So I'm going to use this highlighted triangle, and it's a right triangle. So I'm going to apply the sine ratio to solve for the height. So sine of 42 degrees. And just to remind you, the sine of an angle is sine of theta, for example, equal opposite over hypotenuse. So in this case, in the triangle we formed, Sine of 42 degrees equal opposite, which is h, over hypotenuse, which is 10. The hypotenuse is usually the side facing the 90-degree angle, and 42 degrees has an opposite side, which is h. I'm solving for the height, so I'm going to cross multiply. And I'm going to use the calculator for that. I'm going to put 10 times sine of 42, and I'm going to make sure my calculator is on degree, and I should get something very close from 6.69. After I calculate the height, I'm going to need to compare it with the side facing the given angle. So here's the given angle. The side facing the given angle is this one. So comparing 6.69 to 7, definitely this is less than 7. So the height is less than the side. And that's how I'm going to decide according to the three possibilities. When the height is less than the side, this is when we get two triangles formed. So that's my decision. I didn't solve for the triangles yet, and that's why it's only part one of the ambiguous case is deciding whether there's a triangle to solve for, or two triangles, or no triangle. So I got two triangles in this case. Now it's your turn to practice on page 439. 13 through 18, you're just going to make a decision and you're going to decide whether the given measurements give you 0 triangles, which means no triangle, 1 triangle, or 2 triangles.